Got to give the people, give the people what they want. That's right. It's me, Bass. I'm back. Got another special guest host in the house. You might see her pop in and hop out right quick. You know what I'm saying? So, write this down. Connecting explicit and recursive rules. All right. So, a recursive rule is a rule that allows us to write a sequence given the first term. I must have one term to get to the next one, all right? So that's what we have. You should pause it right now and get that written down. Cool, you paused it because you're smart and you did that kind of stuff and you follow directions. That's great. So let me get you an example of a recursive rule. So an example of the recursive rule is when I have like a to the 0 is 18. There's your first term. And to get your current term, right, we take a to the n minus 1. I should write that smaller. Subset a to the n minus 1. We'll call it plus 6, right? This is the recursive rule that we've talked about all this time. You look like you want to...
Wow, that is so cool.
Oh,
that was so
you feel the love? You feel the love right there? She's feeling it. There's the recursive rule. So, your starred piece right here is the most important part is I need to know. I can't wait to watch this. A starting point to get to the next term. You need to know a starting point to get to the next term if it is recursive. I can't pick a random. I can't just pick any random term and figure it out. Doesn't work that way. It's not so cool. Alright, so you're going to pause. You're going to get that stuff down. Cool, you did that. That's the beauty of technology and video and stuff of that nature. So then, from there, we're going to talk about an explicit rule. That is just bad. Explicit rule. Okay? So for this one, this type of rule allows you to calculate, you should underline that, to calculate any term in a sequence. How do you feel about these explicit rules here, Marion?
I'm feeling pretty good. I think Mr. Bass here is doing a great job, so...
You are a perfect hype woman. This, I think you might be hired. You might be hired.
Yeah? Am I going to get paid?
No.
Okay.
So for example, where'd it go? So an example of an explicit rule says if I take something like f of x equals 6x plus 18. This isn't recursive because I can just figure out any term. If I want to know the third term, I plug in a 3 for x and I can figure it out. If I want to know the 29th term, I can plug in a 29 for x and I can figure it out. I don't have to know what comes before that term to figure out the term that I'm looking for. So we're going to put this star here, and it says, I can figure out we'll just call it the 25th term. If I wanted to, I can figure out the 25th term just by plugging in 25 for x in this situation. That makes it explicit, okay? There's one more thing to get. This is a short video. You should like these short videos, hopefully, because they won't always be so short. Sometimes they'll be longer. This one is just a little bit of information. I'm not going to make you do more than you need to do, so I'm going to make sure you have some stuff down. Thing to know about recursive rules. Recursive rules are always discrete. Hopefully you remember what discrete means, which if you were graphing them, there would be points that are not connected to each other, right? This would be a discrete if this was on a graph. Recursive rules are always discrete, and explicit rules are also always discrete. But there's a caveat. When describing a sequence, and that's very important. If you're using an explicit rule to describe a sequence, it's always discrete, okay? That's it. That's what I got today. This isn't that much. This is not that hard. Marion, what do you think? Do you think you can handle this?
Yeah, I could handle it.
You hold it down for the west side?
Yeah.
East side too?
Yeah.
Nice.
Yeah.
I appreciate that. For Bass, for Marion, we out. That was easy.